Dear students, we have already started with structure of atom, and in last class we talked about dual behavior of electromagnetic radiation. Today we'll talk about the spectrum of light. Light is also electromagnetic radiation. What happens when it passes through prism? Different type of spectrums are obtained. So let's talk about spectrum. What is a spectrum? You might have noticed the rainbow after the rain. Then white light or sunlight which is passing through the suspended water particles, then it splits into 7 colors, and those colors are visible to us, that is vibgyor. That gives rise to a spectrum. So we can say the splitting of a beam of light, it could be sunlight or any other light, into radiations of different wavelength or different frequency after passing it through prism. In case of rainbow, water droplets are acting as prism, but generally also you might have seen when a white light is passed through prism, it splits into different colors of which have different wavelength or different frequency. This phenomena though is called as dispersion, but the pattern of radiations which are obtained after dispersion, that is called as spectrum. So I'll say the splitting of a beam of light into radiations of different wavelength or different frequency after passing it through prism is called dispersion, and the pattern of radiation obtained is called spectrum. There is an instrument which is used to separate these radiations of different color, and that instrument which is used to separate is called as spectroscope. So what is a spectroscope? The instrument which is used to separate radiations of different wavelength. Spectroscope consists of two things. One is a prism and other is telescope. If along with this we also add photographic film, then it becomes spectrograph. So here you can have the recorded observations just to analyze a particular sample also. I'll discuss it later on. You know, spectrum can be classified into two. And how will you classify? What is the basis? It is depending on source of radiation. I'll explain it. It has been classified into two. One is emission spectrum and other is absorption spectrum. Emission spectrum is further classified into continuous, and this is discontinuous, which is also called as line spectrum. First of all, we'll start with emission spectrum. And in emission, I'll start with continuous spectrum. There is a prism here. A white light is passed through it and it disperses into 7 colors. 4, 5, 6, 7. You might have noticed that you get here VIBGUR. And what is the range of their wavelength? Generally, it is from 400 nanometer to 750 nanometer. This is the range of wavelength for visible region. You know, violet has least wavelength, whereas red has the maximum wavelength. So the color which has the least wavelength will bend the maximum, whereas the color which has the maximum wavelength will bend the least. The different colors or splitting of this white light into different frequencies or wavelength obtained is a continuous one. Why do we call it as continuous one? Because all the colors are merged with each other. Violet is merged with indigo, indigo is merged with blue, blue is merged with green, green with yellow, and so on. So there are no sharp boundaries between the color. So that is why it is called a continuous spectrum. Children, let's talk about discontinuous or line spectrum. You may take a gas or maybe vapors of a volatile substance. Vapors of these volatile substance are passed through a flame. They will come in the excited state. These vapors of the substance which are there in the excited state will produce a light, and this light is directly passed through the prism. And in this process, you will obtain a spectrum which is not a continuous but a discontinuous one. There are some light bands which are separated by dark colors. Beta, I repeat it with an example. If you take a volatile salt like sodium chloride, it is placed in the flame at low pressure. You will see a light of certain color is emitted out, and the color of the light depends on the nature of the substance. If you take sodium salt or sodium metal, then yellow color light emits out, and if you take potassium or potassium salts, violet color light comes out. This light is then passed directly through the prism, and then it is resolved through a spectroscope. You will see no continuous spectrum is obtained as you have seen in the earlier case, but you will get isolated colored lines. These are the isolated colored lines, and they are corresponding to the fixed wavelength. These colored lines are present at the specific wavelength. They are the characteristics of an element. So they are also called as fingerprints of a particular element. Why do we say so? As two people don't have same type of fingerprints, in the same way two elements will not have the same type of line spectrum. They have characteristic wavelength at which the light bands or light lines are there. Children, why do we call it as line spectrum? Because it is not continuous. These are the distinct lines or colored lines are there which are separated by different bands. So there are some features about it. One is it is characteristic of an element. They are also called as fingerprint of elements because the spectrum of one element differs from the other one. This is the unique feature of a particular element, and it is used in chemical analysis. If you have a sample in which more than one elements are present, then you can identify which elements are present. So I can also say to identify and estimate the elements present in a sample. It has also helped in the discovery of elements like rubidium and cesium. Children, let's talk about absorption spectrum. What we have discussed till now is continuous and line spectrum, and both of them are part of emission spectrum. In emission spectrum, the sample or white light is directly passed through the prism. But see what happens in case of absorption spectrum. In case of absorption spectrum, white light is first passed through a medium or solution. This solution will absorb some of the radiations, and the transmitted light is then passed through the prism. And then some spectrum is obtained here. What kind of spectrum is obtained in this case? Some dark lines are obtained in the otherwise continuous spectrum. And where are the dark lights in this case? Dark lines are obtained at the same place where colored lines are obtained in the emission spectrum. I can also say wavelength which is absorbed were the same as were emitted in the emission spectrum. जो वेवलेंथ एब्जॉर्प्शन में एब्जॉर्ब हो गई थी वही सारी वेवलेंथ एमिशन के केस में एमिट आउट हुई थी. So the two spectrums, that is emission and absorption, are related to each other in the same way as the photograph and its negative. You might have observed there is black color of hair in the photograph, but there is white color of hair in the negative of the photograph. So absorption and emission spectrum are related to each other in the same way as photograph and negative of the photograph are related to each other. Can you write down the distinguishing point between emission and absorption spectrum? Children, you may note down the points. Children, you may write down in emission spectrum It is obtained when radiation from the source is directly passed through the prism. Whereas in case of absorption, it is obtained when white light or radiations is passed through a solution or some medium, and then transmitted light is passed through prism. This is first main difference. Second, you can say in this case bright colored lines are obtained, whereas in this color it consists of dark lines in the otherwise continuous spectrum. Emission spectrum could be continuous or discontinuous. It is of two types, whereas this is always discontinuous. These are some of the differences between the two. Children, let's talk about line spectrum of hydrogen. Children, there is hydrogen gas through which some electric discharge is passed. Some light is emitted out of it, and this emitted light is examined with the help of a spectroscope. And different lines are obtained, or different lines which are obtained are grouped into different series, and the series are named after their discoverers. So there are 5 series which are obtained here. I'll make a table here. Children, N1 and N2 are the shells where the electrons of hydrogen atom get excited. N1 is the lowermost level and N2 is the maximum limit till which it can be excited. So the first series which were obtained is named as Lyman. Here the lower level is 1 and higher level is 2, 3, 4, 5, 6. It could be any. And next series is Balmer, in which again few series are grouped together. Lower level or the shell, lower shell in which electrons are present is 2, and higher they could be excited to 3, 4, 5, 6, something like this. Third series is Pasture, fourth is Bracket, and last is Fund. And in all these series, lowermost level is fixed where the electrons are present, like 1, 2, 3, 4, 5, and higher level is 1 higher than the lower level. Like in this case, it is 3 is the lower level, So it is 4, 5, 6. If 4 is the lower level, it could be 5, 6, 7, 8. And in this case, higher level is 6, 7, 8, 9. So when an electric discharge is passed through the hydrogen gas, it dissociates into two hydrogen atoms. They will reach to the excited level, and to different levels it can be excited from the lowermost level. So many lines are obtained, many colored lines are obtained, many emission lines are obtained. They have been grouped together where the lowermost level is 1 and the higher could be 2, 3, 4, 5, 6, 7. Then they are grouped together as Lyman series. And the lines in which lower level is 2 but the higher level is 3, 4, 5, 6, then they have been grouped together as Balmer, and so on. So there were 5 scientists. Based on the name of the discoverer, they have been grouped as Lyman, Balmer, Paschen, Brackett and Fund. Children, this is all for today. Let me revise what we have done. Children, we started with spectrum. You know, whenever a beam of light is passed through prism, it disperses into different frequencies and different wavelength, and the pattern which is obtained is called as spectrum. And the instrument which is used to analyze this pattern or to separate these lines is called as spectroscope, and sometimes these observations are recorded through spectrograph. Spectrum, depending upon the source of radiation, has been classified into two. One is emission, other is absorption spectrum. Emission is further classified into continuous and discontinuous. Children, you know, in continuous, as we have discussed earlier, there are no sharp boundaries. All the colors are merged together. Whereas in discontinuous, which is a line spectrum, distinct colored lines are obtained. And you will see that they are the characteristic of an element. That is why they are also called as atomic spectra, because they are characteristic of an element. Sodium spectrum is different from potassium. Potassium spectrum is different from calcium. So they are fingerprints of the element. These lines are obtained at specific wavelengths, and they are also used in chemical analysis to identify and estimate the elements. Absorption spectrum is very different from emission spectrum. In emission, we are directly passing the light through the prism, but here in this case, light is first passed through a solution. Some amount of light is absorbed, and the transmitted light, which is not absorbed, is passed through prism. In this case, you will obtain dark lines, and these dark lines are present at the same place where colored lines are present in the emission spectrum. So the two are related to each other as the photograph and negative of the photograph. This is the main difference between the two. And then we have discussed line spectrum of hydrogen. Children, in line spectrum, you will see when an electric discharge is passed through hydrogen gas, it dissociates into two hydrogen atoms and some light is emitted. This light emitted is analyzed through spectroscope and many lines are obtained. And all these lines are grouped together based on the lowermost level of the shell in which electrons are placed. In Lyman series, lowermost level is 1 and electron can be excited to any higher level 2, 3, 4, 5, 6. In Balmer, lowermost level is 2 and electron can be excited to higher level of 3, 4, 5. So higher level is always 1 greater than the lowermost level, and so on. You can say the electrons are present. Children, you might question why we have taken hydrogen atom to study the line spectrum. It is so as the line spectrum of hydrogen is the simplest and it becomes more complex for heavier elements. This is all for today. Thank you.